Okay, this video is going to go over volume, which is something that we can only calculate with 3D shapes like this one. So in the previous video, we looked at perimeter and area of 2D or flat shapes. We can still find perimeter and area of 3D shapes, but we can also do volume, which is we can fill up a 3D shape with something. So for example, on this video, we're going to be looking at this plastic container that I have filled with centimeter cubes. And so just like when we did area, we talked about how many squares, flat squares would cover the area. Volume is how many 3D small cubes will fill something. And so volume is what we will calculate today, or focus on calculating, but we will still look at perimeter and area a little bit with this. So if I were to want to know the perimeter of this 3D shape, I would do just like I've done before, and I would just look at the outside edges of this shape. So the perimeter would pretty much be a square. So if we flip it over, we can measure how many it takes to get around the perimeter. So it's 1, 2, 3, 4, 5, 6, 7 squares this way. And then 1, 2, 3, 4, 5, 6, 7, and then all the sides are actually 7 because we've already said this is a cube. Well, right now it appears to be a cube. So we have 7, 7, 7, and 7. So if I wanted to find the perimeter, like we did in our other video, if I wanted to know the perimeter of this shape, the distance around the outside, I would add all the sides, which would be 7 plus 7 plus 7 plus 7, which means technically it takes 28 centimeters to go all the way around the outside of this shape. And I can verify that by counting the fact that if I counted all the way around, I would count 28 of these little cubes all the way around. I could also find the area, so I could also tell you how much space this cube covers when I set it down somewhere. So the area would be the amount of space that this is covering wherever I sit it. So even though it has height because it's 3D, it doesn't take up more space than something else. It's just still covering that same square shape when I sit it down. So the area is still going to be length times width because it's a square and not a tricky triangle. And so since we know it's 7 on this side and we know it's 7 along this side, then to find the area, we will just multiply length times width. And that would tell me 7 times 7 is 49 centimeters squared. We multiplied two things and we have a little squared symbol to show that on area. Now, if I wanted to verify that 49, I could flip this over, or maybe probably easier to count it from the top where you can see it better. I could count every single one of these squares that I can see, and what that would come out to be would be 49 total squares inside of there just on that top layer, or the bottom layer if you're thinking about it that way. Now of course if I laid this on the side, it would take up a different amount of space, because what we're going to find out here in a second is that this is not actually a cube, because if I were to lay this way, it would actually is going to be more of a rectangle shape. So if you were looking at this side, this is no longer a square. So if I wanted it to take up more or less space, I would need to know the area of that side versus the area of this side. Now just glancing at these, you could probably estimate that this one probably takes up less space. But that's calculating area, which we're not going to do just yet of this side. What I'm more interested in doing is moving into that third thing that we want to do today, and that is volume. So we know that it is 7 down this way and 7 down this way. What makes this 3D is it has a third number. Its third number is its height going up. And so let's count how many it is up. 1, 2, 3, 4, 5. There are 5 cubes high. And so what that means is that we need to calculate the volume, which we want to know how many cubes are inside of here. Anybody have a guess how many cubes are in there? This is the way you always will win estimation jars. If you can calculate volume, using the formula I'm about to give you, you'll always win estimation jars, like when they fill the jars with candy and they want to know how many. Use this volume formula to win. So, the volume formula that I'm teaching you is length times width times height is your volume. And volume is always going to be done in units cubed, which means you're going to see a little 3 up there. Area, we always saw units squared because we were multiplying 2 things to get area. Volume, we use a 3D shape, so we're going to multiply 3 things, length, width, height. And we're going to have units cubed, meaning that's how many cubes it would take to fill this. So, if I go back to my calculations here, if I wanted to calculate volume, which I do, it's the purpose of this video, volume is length times width times height. For this particular cube, it is 7, well, it's not a cube, I keep saying that, but cubes would be 7 high, and this isn't. This is 7 for length times 7 for width times, we counted 5 up on there, so 5 for height. And I would simply put this in my calculator. You do not have to do this by hand. Type 7 times 7 times 5, which is another way, which would give you 245 centimeters, and again cubed because we're multiplying 3 things together, length, width, height. So that means that filling this, the volume of this rectangular prism, filling this rectangular prism are a total of 245 of these cubes. And if you don't believe me, I would be happy to let you borrow this cube and dump them out, and you can spend your time counting them. But this is a formula for volume that works every time on a rectangular prism. And so it is 7 this way, 7 this way, and 5 this way. We take our 3 numbers on our 3D shape, we multiply them, and we get 245 cubes. Accurate every time. Also, feel free to use this and win the next estimation jar that you're a part of, because this is a formula that will help you have a pretty good estimation on just about any 3D shape. So now you should be able to calculate the volume of any 3D shape. Length times width times height will give you a number of units cubed. And then based on our other video we did, you should be able to also find perimeter and area of any flat rectangle, square, or triangle. So at this point, we should be able to calculate all 3 of these, perimeter, area, and volume, where needed.